I'm Tim Ventura, and we're joined today by Brad Templeton, a well-known software developer, internet entrepreneur, online community pioneer, publisher, writer, photographer, civil rights advocate, futurist, public speaker, educator, and self-driving car consultant. Brad has a BA in computer science from the University of Waterloo and a long career of remarkable achievements, including his current roles as a speaker, writer, and consultant at Robocars.com, Chairman Emeritus at the Electronic Frontier Foundation, Chair of Networks and Computers at Singularity University, and former technical and board member at BitTorrent, self-driving car strategist at Google, advisor to DeepMap, Tilt5, Quant Energy, and much more. Brad, welcome back. You have an illustrious career. It is a pleasure and honor to have you with me today, sir.
Good to see you again. And I was, of course, talking with you not that long ago. And we talked about a lot of futurist topics, about singularity and about AI and so on. But in looking at your channel, I noticed that your viewers are particularly interested in the question of aliens and where they are, whether they're here, or what it means for us to interact with other intelligent species. And so I've recently been writing an article on that very subject. The answer may not satisfy some of your viewers, but nonetheless, I thought it would be of interest to them.
Well, I appreciate your going over this with us. I mean, so you've done some presentations in the past, and I'll get to that next. But you have talked at length about SETI and I guess some speculations on the Fermi Paradox, as well as dark matter and energy, and all of that is incredibly intriguing. So I want to start out, again, today we're discussing extraterrestrial civilizations, Fermi Paradox, dark matter, but let's start with an article in The Guardian entitled, "If Aliens Contact Humanity, Who Decides What We Do Next?" This was actually where I was first introduced to you. You had some critical comments about this article, so let me start there. What was wrong with that article and the premise that they had?
Yeah, well, the question they ask, who decides what we'll do next? My answer was, it's foolish to think that we get much say in it. That basically the aliens, if we were to have communication with them, are going to be a great deal more sophisticated than us. And later on in this discussion, I'll go into how they're going to be ridiculously more sophisticated than us. And so for us, if this were to happen, I don't think it's going to happen, but if it were to happen, it would be our first rodeo, but not their first rodeo. And they would have been through this before, understand a great deal more about the process of first contact, and thus really be controlling everything that goes on to a reasonable degree. Now people say, how can that be? We're just receiving their signals. Again, not their first rodeo. And so they'll have been through that situation. And so I thought that we like to imagine what we should do, or, what's the right thing for us to do. And I don't know if it's going to be all that important what we want.
Well, I think that's an incredibly important point, and that's why I wanted to start there. I think that Hollywood often portrays ET as being somewhat on a level of technical or cultural, sociological parity with humankind, right? And they do that so that they can do drama and conflict, and there's a fairly even match. But in reality, I think it's probably more likely to be something like Carl Sagan's Contact, right, where they are so much more advanced than us that they probably know the entire story back to front because they have gone through it so many more times.
Well, I'll put up a little illustration that I made to illustrate what I like to say, which is we are the stupidest race in the galaxy. And by that, I mean, if anyone we could talk to is going to be smarter than us, because we just figured out technology and communications in the last century. So by definition, we're the baby, and anyone else has to be older than us because there's nobody younger than us. If you're younger than us, you can't talk. And so therefore, we are the stupidest race in the galaxy, and we don't like to think about that too much, but that's the reality of it. There's an amusing story behind this picture, by the way. This picture I asked Google Gemini to make, one of the AI image generators. And when I asked it to draw the Earth with a dunce cap, it said, I can't draw that because that could be demeaning to the Earth. So as people know, there's been a lot of headlines about that this week, that Google went a bit overboard in trying to have their AI engine not ever do anything that could offend anybody. In fact, went nuts, and if you asked it to draw German soldiers, it gave you a very diverse culture of Nazis, which is not exactly what the German army was like at that time. So people realized, okay, that's clearly not the right direction. Google apologized for that. They pulled it down, so you can't make it in. But after it said it wouldn't make it, I said, okay, draw the Earth with a hat that's cone-shaped and has a big D on it. And it said, okay, and happily did that for me. So it ain't too hard to trick these AIs right now, even if they are trying to govern the morals of their users.
The subheading of the article that you were commenting on reads, scientists are setting up a post-detection hub in Scotland, and they're worried that concerned humans would react like headless chickens. That is, if we receive a signal from SETI. And that prompted me to think, well, what does happen if we get a signal? Do we have any kind of a procedure or process in place, or is it just kind of like, hey, guess what? We're not alone?
Well, the good news on that question is we're not going to get a signal. So we don't have to worry about that too much. Or at least we won't get one unless they're ready. And one of the hubrises, unfortunately, of SETI is based on this idea, again, that we are the stupidest race out there, which is to say that there are intelligent beings out there. They're very smart. They're older than us. They've had technology for, and not just a little bit longer than us. They've had technology for tens of thousands of years, longer than we have, millions of years longer than we have, and that they want to talk to us, but they can't figure out how. Well, of course they can figure out how. Of course they can figure out how to do it on their own terms. So many SETI people are hoping that, all we have to do is just look deeper look into the noise, look for hidden signals. That's not how it'll be. If you calculate, for example, we human beings, again, very young, only a century of technology, we've already sent space probes out, a small fraction of a light year from our star. We also have the ability to build lasers, which, if you were to point them at another star system, and you want to spend the money, we don't do this because this would be pretty expensive for us, again, because we're pretty stupid. But Elon Musk could do this. For example, one single human being could launch a space probe out to about 1/10 of a light year away. It would take a few years to get out 1/10 of a light year, a few decades. I mean, it wouldn't be quick, but it could go out there with a laser on it, with a nuclear reactor, and it could send laser pulses at target stars that you put in a list of names of places you might want to send a signal to. And people, if there were people, but beings sitting on the ground of a planet around such a star would look up in the sky and see the sky blinking. Nothing subtle about it at all, if we wanted to spend the money to do that. And even we can do that. Now, another thing that even we ignorant humans know is how to detect planets around other stars. And we've detected several thousand of those, even a few that are similar to the Earth in rough characteristics, might be able to carry life of the sort that we have. And of course, we don't even know what possible forms of life there could be. So even we can do that. And we've even got the ability now to do spectra on the atmospheres of these planets and look and see, is there anything unusual in the atmosphere, any unusual gases? Well, our atmosphere has a very unusual gas in it called oxygen. I'm fond of it. In fact, it's my favorite thing in the world. You discover when you go up to very high altitude that oxygen is your favorite thing in the world. Nothing you enjoy more than oxygen. Anyway, there's oxygen, free oxygen in our atmosphere. Free oxygen just doesn't sit there. It's a very reactive gas. So for there to be oxygen in the atmosphere of a planet requires something unusual to be going on. It could be chemical processes, but of course, in the only instance we know of, it's because of biological life. So any beings at all who are out there smarter than us have already known there was life here for about 1.5 billion years. They have known. So they've known that there was something here for 1 billion years. They know how to find us. They know how to see us. So it's just ridiculous to imagine there are aliens out there who are interested in other species. They might not be interested, but if they are interested, they know we're here. They've known we've been here before we knew we were here. They knew we were here before we even could speak. And they would have, again, if they're interested, if they're the sorts who would travel, they would have sent probes here. It's kind of in an Arthur C. Clarke 2001 sort of sense, perhaps, about where David Brin's existence, if you've read that, it's another SETI novel. They would have sent probes here, again, before we knew we were here, and those probes are not talking to us. They could, again. So the idea that they just can't figure out how to talk to us, or they can't talk to us, it's just, I can't say it's impossible, but it's just so unlikely. So the reason we're not communicating with aliens is either they aren't there, which is possible. People, talk, but that's sort of the first and degenerate answer to the Fermi Paradox, which we'll talk about. And I bet most of your podcast listeners are familiar with the Fermi Paradox, is just to say, well, we're the first. I call that the anti-Copernican heresy. So Copernicus was, of course, treated as a heretic because he said the Earth is not the center of the universe. It's not the most special planet out there. It's just an ordinary planet orbiting its star. And at the time, everyone said, die, heretic. Well, they didn't kill him. They killed Bruno, some other people who said that same message. They jailed Galileo for saying that. But anyway, he was a heretic. Today, we have learned he was right, and every time we've doubted he was right, that's been silly. And so if you want to doubt him now and say, no, it turns out Earth is the most special planet in the universe. It's the very first planet in our galaxy, at least, possibly multiple galaxies, to create life. Well, that makes it a very special planet, and so it's complete opposite of what Copernicus told us. Now, most people don't follow that anti-Copernican heresy. People have been driven to it simply because they don't like the fact that there aren't any aliens talking to us. And so they say, it can't be, so there must be none. Because otherwise, how would we not see them? How would we not see, at the very least, evidence of their engineering? They might not want to talk to us, they reason. But, although, again, that bothers people, the idea that they don't want to talk to us. But at least, there's certain things, at least, unless our physics is entirely wrong, certain ways that their engineering should be visible to us. And friends of mine and others have looked. They have searched every galaxy we have a photograph of, and we're getting many more good photographs of galaxies now from James Webb and Hubble. And they've looked for any signs of engineering on a galactic scale. And the universe seems to look entirely natural, if you want to call it. It's wild.
Yeah.
It is not artificial, constructed. And one of the things they look for is the fact that our physics very solidly says two things. One, you can't go faster than light. And two, that if you make use of energy, you increase entropy, which means you redden the energy. And we don't, if those things are not true, then boy, is our physics wrong. Now, again, we're stupid, so it's not out of the question that our physics is wrong. But a lot of other things have to be wrong for those things to be wrong. And so what should happen is if there is an intelligent species out there in the universe expanding, it would create a slightly red sphere. It's a sphere because it can't expand faster than the speed of light. And it's slightly red because you can't make significant use of energy without making the energy redder. Red is lower energy than other forms of energy, other forms of light. So people have looked, and they don't see anything. They don't see stars being covered up with Dyson spheres, which would definitely do this. They don't see any evidence at all, and that bothers them. They say, why, if we believe it's very likely there are other intelligent beings out there, why does the universe look wild, and why aren't they talking to us? Well, why aren't they talking to us is not that hard to explain. We're just boring. Right? We're not ready. There's a lot of creatures that are stupider than us that we don't feel any particular motive to talk to, so it's not hard to imagine beings that don't feel any much motive to talk to us. However, I'm going to go much weirder than this in a few minutes.
Okay, well, Brad, let me dig into the Fermi Paradox a little bit.
Yeah.
Again, the bottom line is, like as you've mentioned, nobody is talking to us. We have been looking, what is going on. This brings it to the Fermi Paradox. So one explanation for this that I believe you talked about at a Foresight Institute discussion was the dark forest theory, that interstellar civilizations avoid detectable contact because of mutual distrust and potential threats to survival. In other words, they are scared. They're scared of us. We're scared of them. or they are potentially scared of the future, right? Like, so they know that our planet is wearing a dunce cap, but who knows? If they open themselves up as we evolve, that might get dangerous. Another...
I don't hold much to the dark forest theory. There's going to be a lot more interest in the Three Body Problem series, which is where that was popularized, as it's coming out on Netflix this month, with produced by the Game of Thrones producers. So it should be quite dramatic and high budget. But sadly, the physics in that book was terrible. And I don't know if we can do spoilers on it. Maybe we shouldn't do spoilers on it. But all right. But it's just safe to say that aliens do know how to triangulate. And I'm afraid the whole plot is based on the fact that aliens can't figure out how to triangulate super intelligent aliens. But I don't know for sure about the dark forest theory. No, I'm not saying I'm not a holder to that. I think they're out there. I think they know where we are. I think they're probably have something watching us. Maybe not. I mean, maybe we're so boring that in fact it's not worth anything to bother us. I think the reverse. I think that once you've had 14 billion years, now we don't know when the first life would have arisen in our universe. Our universe is 13.7 billion years old. We estimate it could be slightly different than that. But if you've had a billion years, if you've had even 10 million years, we human beings as a species are about a couple million years old. We've only had language, though, for less than a million years, well, more than a million years for some types of language, but our complex languages and our technology is only a few, thousand years old. Once you've had millions or billions of years of that, I think it's a likely conclusion that two things happen. One, you get an almost perfect understanding of physics. So what I'm positing here is that physics is finite. There isn't an infinite amount to learn about the laws of physics.
Yeah.
That you go at it for a few million years, you'll have found them all. There may still be things you don't understand, but by and large, you'll have a complete understanding of physics and engineering principles behind it. So you'll have a great deal of capacity and power. The other thing is, and this seems to be a universal trend in life, is towards efficiency. Evolution loves efficiency. The more efficient species is more reproductively scaled. All that evolution does, it doesn't have any mind of its own. It just selects for whatever gives you the most grandchildren. And that's it. That's basically it. And there's two ways. One is it gives you more grandchildren because they have attributes that are better for survival. The second one is that you're sexier to the ladies. Basically, it's usually that way. It's usually most species, it's the ladies who pick and the boys who dance around. It's only humans where the ladies try and make themselves pretty so the boys can admire them. So it's the other way around with most species, but it doesn't matter. That doesn't actually matter. But anyway, those are the two ways that you get more grandchildren. But being more efficient is to not waste resources, to not waste energy. And to be efficient is therefore to be dark. If I can see you across the galaxy, you're not very efficient. You're either deliberately talking to me. Of course, I see you when you're deliberately talking to me. But if you're not talking to me and you're efficient, you're dark. I mean, it would be silly to think we could see the work of any species that was efficient, because even we stupid humans, once again, are already following this path. We're not perfectly efficient by any stretch of the imagination right now. But we began our forays into radio, broadcasting omnidirectional broadcasts out into space, and in the contact, the aliens are portrayed as detecting the first TV broadcasts from Earth as part of the plot there. But very quickly we stopped doing that, and now we send everything through fiber or tight beams, lasers, microwave signals, trying to be efficient, trying not to send information. The other thing, this is less due to evolution, is that your information becomes random because you both compress it and encrypt it. And the better data is encrypted and the better data is compressed, the more it looks like noise. So these are things which we're going on. I'm not saying every species would have to work that way. But efficiency, I do believe, is something that is going to be a universal. Because if you ever get a conflict between two species with competition for resources, the one who is more efficient is going to be the winner, assuming they have the same resources. Okay, if you've got 3 times the resources, you can be a little less efficient. But eventually there's a strong selection for efficiency, which means a strong selection for darkness. And so you will not see aliens because they're efficient.
So going back to the Fermi paradox, that's kind of what you're saying is efficiency is why we're not seeing them. It's not the zoo hypothesis, which is kind of like the prime directive, and it's not the dark forest model where anybody's afraid of anybody. You're just saying that they are highly efficient and they're not focused on us, and so they're going to be dark.
I am sort of this is not the dark forest hypothesis, but I am concluding that at least in our light cone, which is the part of the universe that we can see, there's more to it than that, but it's pretty big, that there's a winner. Because we would see if there were multiple species at war. You're not efficient at war. Victory is more important than efficiency when you're at war. And you're in competition and so on. But if you're just trying to live your best life, whatever type of life you are, then you want to be efficient and you don't make something visible. However, so that supposition says that the universe is, like our galaxy is 100,000 light years across. So that's pretty far, as Douglas Adams would say about space, but it's actually not, in terms of 100,000 years, the time to travel across that or for signals to go across that is actually relatively quick in the history of the multi-billion year history of this galaxy.
Yeah.
And so it's not at all unreasonable to suggest that at least in our galaxy or in the group of galaxies, there might be one winner. A group of galaxies is, tens of millions of light years across. There might be one winner, and that one winner is efficient and out there. So that's a little bit like the zoo hypothesis in the sense that there is one master of space. It's very important, if you try to answer Fermi's question, that you not just think of an example of why. You have to think of a universal example of why. You have to explain why everywhere we look, every planet, every species, everything that could have arisen, all follow your rule. So I think the demand for efficiency is a universal demand, but other things are not. The one thing that people like about the zoo hypothesis is it only requires that the local masters of our space have a prime directive that says don't talk to the children. And there could be others out there that aren't like that. So the question, however, of why we don't see engineering isn't answered by that unless the local masters are not just local and they're masters of the entire galaxy at least and more of it. But that's not out of the question.
Well, so if I can, this takes us into the dark matter aspect of things.
Yes.
And this was a really unique aspect of your foresight presentation. It's something that I haven't really heard before, but in fact, I had to do some research on this to kind of understand how you were approaching it. But what you were saying essentially is dark matter is, like, for instance, in the Milky Way, it's presumed that dark matter surrounds the Milky Way in a halo.
Yes.
And so in this quest for efficiency, ET would be mining and harvesting dark matter, hopefully using dark energy. They would probably be out towards the edges of the galaxy where the dark matter is. We're not going to find them looking towards the center, looking towards stars, right?
Well, that's partly right. Dark energy is really poorly understood, so I don't tend to talk too much about it. I mean, it is true that it's hypothesized by some people to be a significant fraction of all the total stuff. I mean, it's when they call it dark energy, it's not really anything like energy as we think of it. So it's not clear. It's not clear what it is. It's just a thing which is posited to cause the expansion of the universe. But let's leave that out for a moment, although it's interesting to get into in a bit, and just look at the matter in the universe. Well, there's a famous cartoon, which everyone, I think, has seen. I have a graphic of it if you really want to see it. And it's a man is standing by, he's kneeling on the ground by a lamppost, and he's looking for something. And someone comes up and says, "What are you doing?" He says, "I'm looking for my keys." He says, "Well, did you lose your keys here?" I said, "No, I lost them at my car, but here's where the light is."
Yeah.
And this is you shouldn't be laughing at this joke because you've got to have heard it. It's a description of so much of science. So much of all inquiry is, We look where it's easy to look. So this turns out to be very literal when it comes to SETI, in the sense that electromagnetic radiation, light, is all that we can see. It's all that we can detect. We just figured out how to detect gravity waves. We can't really piece anything about them except that they're there.
Yeah.
So electromagnetic radiation. So we have no choice, or have had no choice in all of our history, but to look where the light is. And that does control us a lot. In particular, I did some calculations, and these calculations resulted in amazing numbers. So, for example, all that we know, all that we've ever been, everything that's powered our lives, and let me digress to a little tangent and say, I'm going to give you a very abstract definition of extraterrestrial intelligence, or intelligence in general. And intelligence is something that turns usable energy into thought. So that's about as an abstract a definition of intelligent life that I can come up with. There's a lot of different ways you might turn usable energy into thought. We do it, but we do it by eating food that grew in the ground, or got eaten by an animal that grew in the ground, that was powered by heat from the sun, which got nuclear fusion. Well, hopefully everyone knows that story, because I'm going to get a little deeper into that story. But anyway, all of our thought, our life, is powered by that. Might be other ways to power it somewhere else there. But that's what intelligent life is. Turns energy into thought. And maybe the thought wants to do other things, but it starts with that. So that's what intelligent life is. And we've only looked at what comes from stars. Because all the light we see is generated by stars, or, there's maybe some quasars and black holes. But basically, it's all stars. So stars generate power by hydrogen fusion, and that's because gravity clumps together protons. That's what hydrogen is basically protons, and they came from the Big Bang, and smashes them together hard enough that they fuse into helium, and a little bit of energy is released. Inside the stars, that energy is turned into heat. It bubbles up the star, and the star is what's called a black body, and so it's just very hot, about 5,000 degrees Kelvin. And that radiates electromagnetic radiation, which shines upon the Earth and through all of space. And only a tiny, tiny, tiny fraction of the sun's energy lands on the Earth to feed us. We're very inefficient in that respect. But let's go to the idea of a Dyson sphere, which some people proposed, a sphere surrounding an entire star and harvesting all the energy output of that star. That's what people sort of imagine. That's the big time. The Russian astronomer Kardashev called that a type 2 civilization that could harness all the energy of its star. Type 1 could harness the energy of its planet, and type 3 could harness the energy of a galaxy. But Kardashev was a wimp because it's way bigger than he imagined. But a Dyson sphere gathering all the energy of a star. So it turns out that when hydrogen fuses with hydrogen and produces energy, that extracts 1/150th of the energy in that hydrogen. I'm sure everyone's heard the most famous equation in physics from Einstein, E equals mc squared, describing how much energy is embodied in mass, in matter. So it turns out that fusion is great. I mean, anything that gets anywhere near this mc squared energy is the big time as far as we're concerned, but it's still only 1/150th of the total energy is going to be visible in light. If you got it all, if you had a Dyson sphere, or you were Kardashev 3 and you could capture all the energy of a galaxy, you would only be extracting 1/150th of the energy in that galaxy. Now add dark matter to the game. So dark matter is about 75-80% of the matter in something like our galaxy. It's the regular matter, the protons, what we call baryonic matter. It's a more physicsy nerd term for it, but it means the matter that you and I know and we're made of. That's 1/6 of the total, and the rest is the dark matter. So now we're out to 1/1800th of the energy in the galaxy is present in the light that we see. If we were Kardashev type 3 and could extract all the energy of a galaxy, we would only in the whole life of the galaxy extract 1/1800th of its available energy. That's not very much. It gets worse, though. What we see right now is what was just emitted, or, 5 light years away. It's 5 years ago it was emitted. The total energy over the life of a galaxy is a million times more than the many millions. I actually got to calculate this number. I was just writing down the notes. I should have done it before we had our call here. But basically, we're looking where the light is, and the light is nothing. It's an insignificant fraction of the energy in our galaxy, for example, or by extrapolation, the universe. So when we talk about looking where the light is and looking just where the light is and realizing we're looking at a millionth of the game, or an 1800th of the game if you just want to imagine the entire duration of the universe, and then you think that life in this broad definition is just that which uses energy and turns it into thought, well, what we've seen, thought about, everything we've ever thought about in all of our science and physics and SETI and everything else is looking at a tiny, 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 tiny fraction of what's out there. So I think it's silly to think that's where the action is, that the action is in this tiny bit that we can see. It's not. And in particular, if you think about an advanced species, one that, as I say, has come to fully understand physics, well, they're not going to be all that bothered by this tiny fraction. For them, they're going to want to go and say, how can we play the big game? They will ask the question, first of all, I'm presuming, this is a presumption, that they want more of themselves. Now, all life we know wants more of itself because that's what evolution selects for. If they don't, if they're not interested in expanding or growing, well, then we're not going to encounter them because they're not interested in expanding or growing. So they're not on the table in this discussion. We're only ever going to encounter something that tries to, go beyond where it is, or we go beyond where we are and try and meet it. So they're going to be expansionists. And so you're going to look at all the resources you have available to you, all your money, if you want to put it in commercial terms, and say, all right, we want more of us. We want either more offspring, if that's what we're into, or we want to live longer, or we want to do more. Whatever it is, we want to do that. Otherwise, they could be invisible because they're not going to spread out to us. But if they want to do more, so you look at all the resources available to you and say, how do I maximize what I get with my resources? Now, there's where, if they're smart, they look at this and they say the universe is finite. The universe might not be finite. If the universe is not finite, then they might not ask this question. They might say, look, infinite universe, infinite resources, party, and just go do whatever you want to do. But if you conclude, as we currently believe, that the amount of resources you can get access to is finite, then you look and say, okay, here's the budget. What should we do? And the answer is we definitely would be making use of the dark matter because stars have this bug. Stars, as I mentioned, get collapsed by gravity, and it gets packed so tightly that they set themselves on fire. Well, metaphorical fire. It's nuclear fusion, but kind of fire. And they start burning and throwing all their energy everywhere. It's really wasteful and inefficient, and it's really hot. Now, dark matter doesn't have this bug. Dark matter doesn't interact even with other dark matter. And because of that, at least that's what we believe about it. We cannot make solid statements about dark matter. Our physics is not up to that today. But from what we've seen, we can see evidence that it interacts with anything other than through gravity. And that means that it doesn't burn itself up on its own. It just sits there. If you know how to use it, now we don't know anything about it, but let's assume, I don't think this is a big assumption, that beings with full understanding of physics would know how to exploit the energy present in dark matter. Even we humans can think of a few different ways to do it. For example, a friend of mine had a nice paper. If you can lower things towards black holes, now that's not something we can do, but it's not impossible. You can lower things toward black hole. You could get the energy out of dark matter. It turns out that black holes will destroy matter and turn it into energy. And so it's possible in theory to get 100% of the energy out from that. The reason we see black holes is, of course, because matter and possibly dark matter are falling into them and being destroyed and emitting their essence as energy. So that's one way. Another way is if dark matter has antiparticles, and if our physics says every particle has an antiparticle. So if you could find a way to smash a dark matter particle against its antiparticle, they would annihilate and be turned 100% into energy. So these are just a couple of ways that we humans, with our very simple knowledge, can postulate might be a way to get energy from dark matter. These are beings with a near perfect understanding of physics. If that exists, they would be out there and say, this is where the action is. This is the 99.99999%. That other stuff, it's going to burn out and use up about 1/1800th of its energy, and then it's going to get cold. It's going to turn into brown dwarfs. We can wait. And then we'll get all that energy from those stars once they've turned into brown dwarfs, because why do we want to go down to stars? They're hot, and hot is inefficient, because if a little more physics lesson for those who didn't study physics, but it turns out the efficiency of a process is better when you have a cold environment than when you have a hot environment. Any process where heat is involved, you get better efficiency. You can do computation better when things are cold. In fact, right now, our best efforts at trying to make the fastest computers and quantum computers and so on actually ask us to take them down to temperatures near absolute zero. Again, this is just a few things that we know. We don't really know what they would do, but it's very plausible to think that if you're playing at this level, that cold is what you want. And so being out in the dark reaches of space, using dark matter as you need it, is the path that you would be in. And you would not waste any of that energy. You would physics would demand you emit a small amount of waste energy from having done this, but you would do it so well that you wouldn't be possible for us humans to tell it from noise.
Yeah.
Okay, because there is in our universe a cosmic background about 4 degrees Kelvin. It comes from every direction, and anything that was colder than that would not be visible to us. We couldn't figure it out. So we are everything, unfortunately, in SETI seems to imagine that the action is going to be in this part that we can see and not over there. It gets even crazier than I've just said, though. Once you find you're exploiting dark matter and not stars, so stars, as I say, they're burning themselves out. They have a lifetime. After some number of billions of years, that's a lot to us, but maybe not to other beings, they die. Dark matter doesn't die. It doesn't have this bug. It doesn't clump together. So now you would say, we have the resources of the universe at our disposal. We want to have the most and best life on top of that. How fast should we do it? Well, it turns out as slow as possible is one of the answers. If you don't care about how fast you do it, this is what a computer person might call your clock. Human beings don't have a clock per se. We sort of do. Our brain waves are a little bit of a clock for the brain, but computers, basically, they have a clock and they do instructions at a certain rate. And I'm not saying these beings are computers. I'm just saying they have parallels to what we think of from information theory. If you have a clock, you could run at a very fast clock. On all of our computers, run at a fast clock because we want our computers to be as fast as they can. But if you're not constrained by that, there can be reasons to run it slower. One of the reasons is to wait for all those stars to burn out so you can finally make use of them. But another reason is that if you run yourself slower, if you change your sense of time, you get a magic ability that to do something that I said at the beginning was impossible, which is to go faster than light. So you can't go faster than light. There's a speed of light, 300,000 meters per second, or 3 to 10 to the 10th meters per second. You can't go faster than that. But you can change what the second is. Because if you can change your clock, you can change what a second is. You can make it so that a second is what to us would be many years. And so you could go to Alpha Centauri in a second if you lived that way. And if all of your species decided to live that way, and it had no reason not to, except in a war, if it got into competition with someone else, obviously you'd speed up, you'd be inefficient, you'd have to compete. But if not, just run yourself at a speed. It means you can do more computation. Right now, the barrier, if you're trying to be a computational engine like a computer, it's actually the speed of light. It's actually a barrier. It takes time for a signal to get from one side of a computer chip to another computer chip. If you wanted to make something, a brain of some sort, I don't want to call it a computer chip because I don't want people to think this is just our computers and what we understand computers to be. But if you wanted a big brain, then you'd start saying, darn, it takes too long for signals to get from the left side of my brain to the right side of my brain. But if I slow my brain down, it doesn't. And so suddenly I can have it again. So this points to a suggestion, and Anders Sandberg has also suggested this. In fact, he annoyingly wrote a number of my ideas before I wrote them. It's very rude of him. That it could make sense to just slow yourselves down and wait as long as your competition has been constrained. Now, very obviously, they don't just kill their competition the way the Dark Forest thesis you talked about earlier does.
Yeah.
In that thesis, species say, I don't know what, any new intelligent being could be a threat to me. I better kill them now just to be safe. So as I've said, I don't think that's true because I think they've known about us since before we knew about us. And so if there's anyone out there stamping out the Dark Forest, they would have stamped us out, and they didn't. So therefore, I think we can safely say they're either not there or not doing that, or they're waiting, perhaps, but they're not following that strategy in general. However, we humans, and again, don't want to make assumptions about all species, but there is one example of a species that likes conservation areas, right? That's us. We have already given the idea that, we'll leave some areas in their natural state because it's interesting or valuable to us in some way. And all that's required is that the masters of this galaxy feel that way. And they're willing to let little species like us do our thing. Now, if we start stealing the dark matter, they might change their minds about how tolerant they are, and they might come and say, no, that's for us. Or maybe they'd even say, you guys are cool, come join the party. Maybe that will happen. But not for billions of years, I'm afraid, because they're waiting for the stars to burn out. So don't count on having too many conversations with ET, I'm afraid, in your natural lifetime.
Well, so before we close things down, because again, this is a lot for people to think about, I don't want people to feel negative about the idea of life in the galaxy. What we've been talking about is intelligent, advanced species. And one of the areas that I'm really excited about is the Drake equation, which seems to suggest that for every one of these species, there may be thousands, potentially millions of worlds with life on them, with biospheres. And these could be dinosaur planets, and they could also be planets with ancient ruins of civilizations that have come and gone, right? So there is a remarkable amount that is out there, presumably waiting to be found. And then these species, which the way that you describe them, these are, Kardashev's, stage 3, stage 4, these would be like godlike beings.
Yes.
They would be so far beyond us that we just wouldn't hear from them.
Well, the problem isn't, and it's why Fermi said this, because they were talking about these very ideas, and they were at around the table at, it wasn't called Fermilab then, but anyway, and he just said, where is everybody? Because it was pretty clear from him that all it took was one civilization that wanted to grow out and expand and could travel to other stars or send probes to other stars. It just took one, and they would fill the galaxy in a few 100,000 years. Yeah. And so there could be lots of planets with primitive life, stupid life with dunce caps on it, including our civilization with its dunce cap around this, but not sitting out there unknown, undiscovered by whatever is out there. That's the issue. A lot of people sort of imagine, and most science fiction sort of imagines this idea of first contact, and that's probably wrong. First contact for us, maybe, but not first contact for them. They've seen us, known us, been watching us, and 2001, of course, that was laid out very clearly, and there have been other stories that have also tried to lay that out. Fiction, however, is much more tempted by the idea of a real first contact from both sides, because that's a more interesting drama. But it's not a more realistic drama. If beings ever go out, and there might very well be other dunce cap civilizations out there in very large numbers. But that was the point of Frank's equation, was that it said, unless these coefficients are all really small, there's got to be a lot of them out there. And yet, no, we're not detecting any evidence of them. And that was paradox that Fermi was trying to address. By the way, Fermi's exclamation is unfortunately, for some of your viewers, because I know they won't like to hear this, one of the best refutations of the idea that the government has secret information about UFOs. And it's this. So Enrico Fermi, as we know, was one of the lead scientists on the Manhattan Project. In spite of the Oppenheimer movie, which says it was all Oppenheimer, Fermi was just as important to the Manhattan Project and just as senior. He was at the top of the game in terms of deep U.S. secrets. And the people around the table with him at that discussion were also top scientists with the very highest security clearances. If there was secret contact between aliens and the American government, Fermi would have known about it. He was the clearance to say he would very much have known about that. It would have been very important to his research on building nuclear weapons to defeat the Nazis and the Japanese. So a man who knew there were aliens out there talking to the U.S. government wouldn't be sitting around saying, well, where is everybody? Because he'd know where some of the people were. And so he wouldn't have come up with that question if, in fact, there was a secret file of alien contacts sitting in the U.S. government things, because it wouldn't have been secret from him. From other people in the government, yes, but not from one of the heads of the Manhattan Project.
Yeah, and, just to complicate things even further, from what I understand, the inspiration for that conversation was an article, and I believe it was the New York Times or the Atlantic, one of the major publications of the day, which was talking about space aliens in a UFO stealing garbage cans in New York City. That was what inspired that. And so they looked at this humorous thing, and supposedly, if I remember correctly, he basically just looked up at one point. He'd been doing the math in his head, and he said, where are they? So, yeah, yes. So it's just circles within circles within circles. But now, I did want to ask, do you think that we should be searching the solar system for some kind of artifacts? This goes to 2001. Do you think that we may, basically just find some kind of a monitoring device on the moon or asteroid or something like that?
Well, it's not impossible, but let me lay out how I think this goes. As I said, whatever aliens are out there know we're here, and they are not saying hello. So therefore, they don't want to say hello. And so the only thing that would make it profitable to go looking for them is if something would change about their not wanting to say hello, which means we would have to do something that sort of meets their bar of now being worth talking to. It could be they have a prime directive and they don't have Captain Kirk, because the great thing about Captain Kirk, of course, was he was violating the prime directive left and right. If the aliens had a Captain Kirk, we'd be talking to them because he would have broken the prime directive long ago. But they don't have Captain Kirk, unfortunately. But we would have to look for. So Frank Drake himself actually proposed the right sort of thing, which is after SETI wasn't going very far. He said, why don't we stop looking at radio signals? Well, he didn't say stop looking, but he said, why don't we look for optical signals? Because this was this blinking laser thing that we talked about, that maybe they're sending blinking laser lights at us. And so the right thing to do is not to keep looking deeper in radio, for example, or other things that you've already thought about, but to try and come up with entirely new ways to communicate, like gravity waves would be an example. Maybe they communicate with gravity waves. It's unlikely, but maybe they do. And so I would not fault anyone for saying, let's look to see if anyone's modulating gravity waves, because maybe they're not interested in talking to people until they can see gravity waves, because you're pretty boring until you've done that. Now, turns out we're seeing gravity waves a century after we started playing with radio, so it's really an eye blink to any kind of long-lived civilization. So that might not have been enough. But nonetheless, it's we've got to do something that would make them say they're interested, or that would make us pass the bar. Now, my fear is that bar is very, very high, and well beyond anything that we 21st century humans are ever going to be talking about. But I don't know that. I can't say that with any certainty. Up until the magic moment, the bar could be just around the corner, and so that justifies looking for new things. Now, trying to search the moon. Now, in Clark's story, of course, or at least in the movie version, I read the story, and I'm trying to remember how it was. But in the movie, there was a giant magnetic field around the monolith, if you remember that. And so they had deliberately left a clue to say where the monolith is. And for them, the bar was, this is fiction, by the way, always remember this is fiction. The bar was, do the alien humans get smart enough that they're sending space probes up that could detect magnetic fields, and then they could travel to the moon, dig holes, and unearth your favorite monolith. So that was the bar in that story. So that's a plausible bar, but we haven't yet found anything that would be measuring for that. My point is that when we reach the bar, it will be obvious. Right? It'll be, it won't be subtle, because they either want to talk to us or don't. Unless the test is also we can find a subtle thing. But I mean, so I guess you can't really argue, and people will hold out hope, and so they'll do that. But I would say, that's an outside bet. It's worth taking, but it's not worth banking everything on. Don't bet the farm on finding the buried thing that's hidden. I mean, it could be, but since we don't know anything else to do, we'll probably do it because, we must do something, and this is something, so let's do it.
And from what you're describing, it sounds like they'd be waiting for us to have like a Dyson sphere half constructed before they show up and say,
I have no idea what they're waiting for. I just know that we're not anywhere near it yet. And we can't say what it is they would be waiting for. All we know is they're not saying hello. We know they could say hello, and they're not. But we can't really say a lot about why. Now, the people who believe in UFOs, they think that they maybe just come here and don't care if we see us or not. It's kind of weird. Ufology is a little bit weird about that because it can't make us a mind about are they hiding from us? Are they talking to us? Or are they just wandering around and don't give a crap about whether they see us or not? Only the latter one could make sense, I think. But it doesn't fit, however, with the idea of any sort of prime directive that they're not wanting to interfere with us. But we don't know anything about the psychology of alien intelligent life, so it's pretty hard to make a firm pronouncement about that. I won't say that's impossible, but I don't know. It certainly doesn't make a lot of logical sense what we do see. I mean, because what we see is, as I'm sure has been pointed out in other podcasts you have, now everybody in the world travels with a 4K video camera with them on their body at all times, and the number of UFO videos is going down. Right? So that's exactly the opposite of what you would predict. If they're really buzzing around not caring about what we see or what we don't see, then as soon as everybody got a high-quality camera in their pocket, we should have been flooded with cameras compared to what we saw. 50 years ago, people were making UFO sightings and UFO videos, and people talked about them, and you could never be sure because there were no pics and it didn't happen, sort of thing. And now, there'd have to be pics. If there was anything to see 50 years ago, there's 1,000 things that would be recorded by the cameras in all of our pockets today. So it's pretty obvious that they're not just flying around all the time and not caring if we see or photograph them. You then have to take yourself to a much more difficult proposition, which is that they noticed we all had cameras now, and so they decided to hide now. But then why are they hiding badly? Right? I mean, they would either hide really, really well or not at all. I don't see an explanation for why they would hide badly and occasionally get photographed and occasionally get seen by the odd, warplane and so on. And the fact that almost all and some people would say all of the UAPs videos that do show up do end up having mundane explanations, tells you that it's not that the aliens are hiding badly.
Brad, on that note, I want to thank you so much for your time today. It has truly been a pleasure and an honor having you with me. We've gone through.
I'm not sure everyone's going to like my answer though, because a lot of people. I mean, everyone would love to have the chance to meet other life, of course.
I want to point people towards the Foresight interviews that you've done as well, because you have a lot of content out there, detailed slideshows and graphs. You walk people through understanding what the attraction and the necessity of dark matter is from an efficiency perspective. So let me do that as well. But let me close by asking, what is coming up for you in the next few months this year? Are you going to be doing any more work or speaking on SETI and the extraterrestrial hypothesis?
Well, so I have an article on these ideas, which I've been sort of sitting on the back burner for a while, and I do need to get that out and publish it, and so people will be able to read things with a little more rigor and a little more detail. So yeah, hopefully I should have done that last year, and I just haven't got to it. I maybe want to get some collaboration. As I said, there are some other people who have been thinking along the same lines, and so I want to square all the different thinking that different people have had, and have some more rigor about it, and then get that out to people. I'm continuing to work on self-driving cars, and was advising a major automaker yesterday on that, and I'm going to continue on. And while there have been some bad bits of news of people pulling back, Apple Computer just decided to cancel their project, for example, I'm still optimistic about the ability of that technology to change the world, and also fascinated at seeing what's really the first big battle over AI that we're having. Because now this is not, actually, many people don't know this, but the large language models, like you see in ChatGPT and other things, are being used in these cars. And so it's every sense of the word AI that people have been talking about is showing up in them. And on the other hand, we're seeing the public react in different ways, all the way to arson, maybe. That may have just been crazy mood around Chinese New Year or the Super Bowl, but the battle is begun, and we will see how it goes very soon.
Thank you again so much for your time today, sir.
Thank you.